All right, so the key for the first one is it wants your answer to be in exponential form. Look at your answer. Does your answer have a root in it? You did it wrong, okay? Exponential form, no roots. I want to get rid of the roots, okay? So just start getting used to reading the directions, because on your test it's going to be really important that you read the directions so you know you're answering in the right format. So the fact that I want it to be exponential form means I want the root to go away. If a root exists, that means that you can write it in exponential form. But your exponent needs to be a fraction, right? The only way that something ends up inside of a root is if its exponent is a fraction. So the 27 and the x to the 12th are all inside of the root, meaning to bring them outside of the root, they have to have exponents that are fractions, all right? The numerator is the inside exponent, and since 27 doesn't have an inside exponent, I'm going to put a 1 there. The inside exponent on the x is a 12. The denominator of this fraction is going to be the outside exponent, which is 3, all right? Then yesterday we learned that if it's a number like this, we're just going to type it in the calculator. One thing that I didn't do in your class yesterday that I realized later on affected some people is, depending on what type of calculator you have, so I was doing it all in this one mode, but like if I'm doing 27 to the 1/3 and your calculator looks like that, does anybody's look like that when you do it, where the 1/3's not up top? If you're not looking right, you don't know. If your calculator looks like this, where it doesn't make it an exponent, you've got to use parentheses around this, or you will get the wrong answer, right? If your calculator's the one where the exponent immediately goes to the top, which I think most of you have, parentheses aren't necessary, but for this calculator, it is. So we see that 27 to the 1/3 is 3. If you don't use parentheses in this calculator, you will not get 3. All right, so just if this is the type of calculator you have, make sure you use parentheses. All right, so that tells me that this is a 3. And then this part of it, what I'm going to do is I'm going to see if this simplifies. So I'm going to do 12 divided by 3, math, enter, enter, and I'm going to simplify that fraction. All right, and 12 over 3 is the same thing as 4. All right, so in root form, it's the 3rd root of 27x to the 12th. In exponential form, it's 3x to the 4th. Okay with that one? All right, let's look at the next one. It's inside of the root, so I want to take it out. So I want to take the 768 and x to the 2nd out of the root. In order to do that, each of these things needs their own fraction. Since the 768 doesn't have an exponent, I'm going to give it a 1. So the inside exponent is 1 and 2, and the outside number is 4. If I type that in my calculator, 768 to the 1/4. And again, if we're doing it this way, we need to use parentheses around the 1/4. I get a decimal. Yesterday we learned that if you get a decimal in exponential form, that you just leave it as is. You don't have to simplify it. That's not true in root form, right? In root form, we got to do some stuff. But in exponential form, we're going to leave it. 2/4 though, I can simplify that. All right, so in my calculator, I can do 2 divided by 4, math, enter, enter. That's 1/2. So I'm going to change that. I'm going to keep this part the same, but that's going to become a 1/2. So this is called exponential form. Everybody okay so far? All right, last one. We've got 3 things inside. We've got this, which doesn't have an exponent, so I'm going to give it a 1. This that does have an exponent, and this that does have an exponent. In order to pull them out of the root, they each need to be a fraction that we will divide by 5. So 3,072 to the 1/5. Decimal. I'm going to leave that as is. 9/5. Does that reduce? No. 30/5?
Yes.
6? All right, so I'm going to change that to a 6. So 3,072 to the 1/5, x to the 9/5, y to the 6th would be my final exponential form. Questions? Exponential form. Definitely easier. All right, the second group, and like your test will be, the second group or the second part would be, now I want my answer to be in what's called radical form. Meaning I want my final answer to have a root in it. So look at your answers for 4, 5, and 6. Is your last step have a root? Okay, so radical form means I need a root. So let's look. We've got fractions, and where there's fractions, there's roots. The base stays inside the bottom number. The top number stays inside, the bottom number goes outside. All right, so now we have a root, but we want it to be simplified, right? That's radical form, but we still need to see if it simplifies. So I'm going to do 16 to the power of 1. Which at this point you probably realize anything to the first power just stays the same. All right, so this is the square root of 16. And then from here we do math 5. And you'll get that root, right? The square root of 16 does end up being a nice, clean root. You okay with that? Variables, if the inside's smaller than the outside, you're done, but it's not. That means that we need to split this one up. And we're going to split it up thinking of multiples of 2, because the outside number is a 2. So 2, 4, 6, 8, 10's too much. So we're going to use the 8, which by default makes this a 1. They together need to add to 9. Inside 8 divided by outside 2 is a 4. I just can't forget that there's an X on that. Inside is smaller than outside, so that part is done. This is called radical form.
What square root do you need?
You do not need the 2. You also can write the 1. Like I wouldn't mark it wrong if you kept the 1. It's a square root if there's nothing there, and if there's a 2 there, so whichever you prefer. All right. Next one. There are 2 fractions, and where there are fractions, there are roots. So 243 inside, outside. X inside, outside. So I'm going to math 5 this. Let me just get back to the calculator that most of you guys have. So I'm doing the 4th root of 243. It's a decimal. Now, if it's a decimal in exponential form, you leave it as is. If it's a decimal in radical form, you got to go to the y equals screen. So I'm doing 243 divided by x. All right, what I'm looking for is some x to the 4ths. Right? And that's because this is a 4th power. So I'm looking for 16, 81, 256 is too much. So I'm either looking for 16 or 81. So let's see. I see an 81 pretty high up. And next to the 81 is a 3. That means I can split this up into 81 and 3. And then from here, I would math 5 each of those. One simplifies, one doesn't. So I'm going to change this to a 3, and I'm going to keep this as a 3. For this one, inside number is less than outside number. So you are done this part of the problem. I'm going to leave this as is. My final answer, I'm just going to take those 2 separate roots and bring them together in the same root. This is called radical form. You okay with that? Now, the last question, I want to be in radical form, right? The directions say radical form, but it's already in radical form. So I don't have to do the initial step that I did here. That step's already done for me, right? I don't want you to switch this to exponential form. I still want my answer in radical form. All I have to do is simplify it. So what I'm going to do is just break up I'm keeping it in root form because I want the answer to be in root form, right? And now I just want to simplify each of those. So I'm going to math 5, that 250. It's a decimal, so I'm going to go here. And what I'm looking for here is an x to the third, which is what? 8, 27, 64, 125, 216. I'm looking for one of those numbers to show up in my table. So 125 and 2. All right, and then I could math 5 each of them, but you also have the ability to use this sheet. So if you go to the x to the third, you find the 125, and you go over, you see that this is going to become a 5. So you don't have to use your calculator if you don't want to. Inside 6 divided by outside 3 is 2. I just can't forget that there's an x there. So that's x squared. Inside 10 divided by outside 3 is a decimal, but 10 is bigger, so I'm going to have to split this one up. And I'm thinking of multiples. 3, 6, 9, 12 is too much. So I'm going to use 9 and 1, so I'm still keeping that value of 10. 9 divided by 3 is 3. I just can't forget the y. Inside is less than outside, so I'll leave that. My final answer, I'm going to move some things around. 5x squared y to the third root of 2y. All of the answers in this section should end up with roots. Here are your roots. That's everything we've learned from before break until yesterday. Hopefully you guys feel okay with that. Today we're going to add one final thing, okay? And it involves exponent properties, okay? And because we're working with fractions, it's going to involve exponent properties with fractions, all right? Before I decide to complicate things by making you do exponent properties with fractions, I just want to make sure you know how to do exponent properties without fractions. So we're going to do a really quick refresh. If you want to do this refresh on your own, that's fine. If you feel like you might need help from a partner, also fine, okay? I'm just looking for you to do 9 refresh problems. I don't expect you to remember the rules. I have them typed. So these 3 problems are the multiplication property. Here's what I need you to do it. These 3 problems are the quotient or division property. Here's how you do it. Does that make sense? All right, so there are 9 total questions. I'm going to give you 10 minutes to work on them. None of these have fractions. After the 10 minutes is up, we'll go over them as a class. And then what we'll do is we'll add fractions to them. And then where there's fractions, there's roots. So then we'll have roots with them as well. So it's like a math problem on steroids. Lots. All right, so feel free to work with someone. Feel free to work on your own. We're looking at 10 minutes here. I'm going to set a timer so I stay consistent with that, and then we're going to move on. In a moment, all of those little numbers that you're seeing on this page are going to become fractions. I promise you that doesn't make it harder because you have this fancy calculator that handles fractions for you. The hard part is remembering the rules. So if you can understand the rules, I don't think that what we're about to do next is going to be hard for you as long as you know how to use your calculator. All right? So, multiplication property, it's going to be presented to you in 2 ways. Either like a dot in the middle or like a star sometimes you'll see, or 2 sets of parentheses. Both of that means multiplication. Whereas if you look down at the bottom, you might see parentheses for the power property, but there's only 1 set of parentheses. So the difference is 2 versus 1. All right, so multiplication property says multiply the coefficients, which are the numbers in front of the variable. In this case, that's 5 times 3. All right, so that's going to give me a 15. Keep the base the same. In this case, that's the x. And then add the exponents. So I'm going to do 2 plus 9. And so I get 11 there. So this first one's 15x to the 11. All right, next one. Multiply the coefficients, which are the numbers in front of the variable. 3 times -2 is -6. Keep the base the same. There are 2 bases. There are x's and y's. Now, when I go to add the x exponents together, there isn't an x exponent on this first x. It says, note, if the variable does not have an exponent, write a 1. So I'm going to add 1 for x plus 3 for x. And that's going to be a 4. And then for y's, I'm going to add 4 and then 1, right? Because when there isn't an exponent, we need to add a 1. So 4 plus 1 would be 5. Questions on that one? Don't forget about adding that 1. All right, and then the last one, if I multiply the numbers in front, 10 times 2 is 20. The bases are x and y, and I'm going to add my exponents. -6 plus +10 is 4, and -3 plus +3 is 0. With exponent properties, you don't want to write anything to the 0 power. It just means that there aren't any y's in the final answer. So I'm going to, in my final answer, I'm going to get rid of that y to the 0. Multiplication property. You got a dot in the middle or 2 parentheses. Next group is called the division property. The division property is the easiest one to spot. You're looking at a big fraction, right? So if you have the division property, you're looking at this big fraction, the first thing you're going to do is you're going to divide the coefficients. These are the coefficients. So 8 divided by 2 is 4. You're going to keep the base where the exponent is higher, meaning if I have a 9 on top and a 3 on bottom, I'm going to keep the x on top because 9 is bigger. And then you're going to subtract the exponents. 9 minus 3 is 6. So the answer to this first one is 4x to the 6th. For the second one, when I go to do this division, I get a decimal. I don't want to keep that as a decimal though. So 10 divided by 18. I'm not going to write 0.55556. I'm going to math, enter that, and I'm going to write it as 5/9. Keep the x where there's more. Well, 15 is bigger than 6, so that means that the x is going to come to the bottom. And then 15 minus 6 is going to give me a 9. We okay with that so far? All right, 3 divided by 12 is 1/4. The x's are the same, meaning there's not a specific place to keep them because they're going to cancel out. I'd end up with x to the 0. Whether you put that on the top or the bottom, it doesn't matter because we're not going to write anything with a 0. And then 3 minus, well, don't forget that if a variable doesn't have an exponent, I need to add a 1. So I'm going to do 3 minus 1. I'm going to have y squared, and that's going to be on the top. You do not have to write that 1. Y squared over 4 is fine.
Wait, if you write like x or y with 0, you're like,
Technically, it's wrong, yes. Quotient property. Subtract exponents. So in a moment, you're going to be subtracting fractions, which sounds a lot more complicated than it is, because if I were to take your calculator away, you'd have to make a common denominator, right? And then you would be able to subtract them, but I'm not taking your calculator away. Your calculator will subtract the fractions for you. You just have to know how to use it. All right? And then the last property we're going to do with this unit is the power property. So the power property has a set of parentheses, but only one of them. One of these is going to be, there we go. Only one of them, and there is an exponent on the outside. So it says raise the coefficient to whatever power's on the outside. So 3 is going to be raised to the power of 4. That's not 3 times 4. That's 3 times 3 times 3 times 3. All right? Keep the base the same. Multiply the exponents. Just like we do with our unit, the part of the unit we did yesterday, I would just then type this into the calculator and get a value for it. So 3 to the 4th power is 81. So I get 81x to the 24th. All right? So take the coefficient in front, raise it to the power on the outside, keep the base, multiply the exponents, and then just check the coefficient. For a whole number, if you get a whole number, you change it. The only tough, tricky part about this is when you do something like this. This has a 1, so 1 times 6 is 6. If you don't use parentheses for the negative ones in your calculator, you will get the wrong answer. The calculator will tell you it's negative, but it should end up being positive. So just make sure if you're taking something to a power that's negative, you're using parentheses. And that's all you got here. We okay with that? All right, so now we're gonna do the exact same type of problems, but we're gonna do it where the exponents are fractions. So for the rest of class here, you will need a toolkit and a workbook. Maybe your perfect power sheet. These problems are going to be like everything that we're doing in this unit put together into one problem.
So when's the test?
Your test is next Wednesday. All right, so just like while you're getting this stuff out, overview is today we're going to do with fractions, we're going to do the product property, the multiplication property, the division property. Then tomorrow we'll do some power property with fractions and just practice. Monday, we're going to do stations with all of the exponent properties, practice. Tuesday will be a traditional test review day, and then Wednesday is your test. So there's plenty of time for practice between now and Wednesday. Technically, you're not learning anything new. Okay, it's going to present as new notes, but you know how to do exponent properties, and you know how to do roots. We're just bringing those two things together. But even though it's not new, we're finishing the notes tomorrow, so like it'll feel good. All right? So, use the exponent property to simplify the expression. If the simplified expression has a fraction as an exponent, then you can write it in radical form. So we're just bringing two ideas together. All right, so this first one is a multiplication problem. You don't see the dot in the middle, but it technically is two things written next to each other. I've got this 4 to the 1/3 written next to this 4 to the 2/3, so technically there's a dot here. That 4 is not considered a coefficient right now. It's below an exponent, and if something is below an exponent, it's called a base, all right? So I am going to keep the base the same. So the product property says that we multiply coefficients, keep the base, and add the exponents. And even though the 4 looks like it's a coefficient, it's not. Because if it's below an exponent, then it's considered a base. I think basement. If it's below something, then it's a base. All right, so I'm going to keep the 4 the same. And I'm going to add the exponents. Which they actually, in this one, already have a common denominator, so you can just add them yourself. However, you don't have to. You can go to your calculator and just do, there's no fancy parentheses involved. You can just do 1 divided by 3 plus 2 divided by 3. That's it, right? The calculator will do the work for you. You probably already knew that one was a 1. All right, so this becomes 4 to the first power. What do we know about anything to the first power? It's just 4. If you want, you can type that in your calculator to check it, but it's just 4. All right, the next one, now the 3 and the 5, see how they don't have exponents on them? Those are considered coefficients now, whereas the 4 did have an exponent, that's a base. So just kind of trying to understand the difference between base and coefficient. So now the 3 and the 5 are called coefficients. Multiply the coefficients. 3 times 5 is 15. Keep the base the same. That's B. Add the exponents. So I'm going to do 1/4 plus 1/2. That's not 1/6. That's not the way fractions work. Okay? So instead of doing, adding that together like that, do 1/4 plus 1/2. Do it in your calculator. If you get a decimal, I need you to enter it. So you're writing it in fraction form. So that's 3/4. So I have 15B to the 3/4. Use the exponent property to simplify the expression. If the simplified expression has a fraction as the exponent, then you can write it in radical form. Okay? So this is called exponential form. But I can also write it in radical form because of this fraction. There is one fraction, meaning there is one root. The fraction belongs to the b, not the 15. The numerator is the inside number, the denominator is the outside number, and that 15 doesn't have a fraction, so it just stays as is. Now that I have it in what's called root form, I would see if it could simplify, but this one can't because the inside 3 is smaller than the outside 4, so it's actually done. This is considered exponential form versus radical form, and we did that all from an exponent property. We okay so far? All right, next one. You don't see the time symbol there, but two things next to each other implies multiplication. There's no coefficients to multiply, so I'm just going to keep the base, and I'm going to add the exponents. I don't need you to be able to add this in your head. 3/4 plus 2/3. I'm just doing 3 divided by 4 plus 2 divided by 3. 17/12. This is called exponential form, and it is as simplified as I can get it. 17/12 doesn't reduce. The calculator would have done it for me. If the simplified expression has a fraction as an exponent, then you can write your answer in radical form too. So because I have a fraction here, I can do radical form. Where there's a fraction, there's a root. The base is x, the inside is 17, and the outside is 12. Can I break that one up? Yeah, 17 is bigger than 12, right? So I can split this up. Any ideas on what multiple of 12 I pick? 12. Which means this is going to have to be a 5 so that it adds to 17. 12 divided by 12 is 1, but don't forget about the x. And you don't have to write the 1 if you don't want to. Inside is less than outside, so I'm just going to keep that as an x to the 5th. So my final radical form would be x, 12th root of x to the 5th. All right, last one. Hopefully you see that 2 doesn't have an exponent attached to it, which makes it a coefficient. But the other term doesn't have a coefficient. So you're either thinking I'm multiplying by 1, or you can just carry the 2 down. There's nothing to combine the 2 with. So multiply the coefficients, keep the base, add the exponent. So I'm doing 2/3 plus 8/3. This one has a common denominator, so if you want to do it without your calculator, you could. I'm not asking you to, though. If you get a decimal, just enter that decimal so that you're writing it in fraction form. So this is 2a to the 10/3, and that's called exponential form. If exponential form has an exponent that's a fraction, then you can write radical form. There is one fraction, so there is one root. The fraction is for the a, which means that 2 is just going to stay at 2. Can I break down this? Yes. What multiple of 3 should I use? 9. Which means this one has to be 1, right? Because I need it to add to 10. And this guy just stays. 9 divided by 3 is 3. Don't forget about the a. Inside is less than outside, so I just leave it alone. From here down is what we did on Monday and Tuesday. The new step is the first one. Knowing to multiply the coefficients, keep the base, add the exponents. And it's not even really a new step, right? You know how to do that. We're just now doing it with fractions. All right, I'm actually going to end with doing just one practice with this on your own and not doing division today. I don't want to kind of rush it, and we only have 10 minutes left. So we're going to end with this. This problem is on page 20 of your workbook. I want you to use the product property, multiply coefficients, keep the base, add the exponents, and if the product property ends up having an exponent that's a fraction, I want you to write radical form as well. And we're going to end here. So just keep this out so that we can go over this one before you head out. All right, I'm going to take a moment to stop you, and let's check the exponential form before you get too far into radical form. Because if your exponential form's not right, then your radical form's not going to be right either. So let's just do a quick check-in on exponential form. We're going to multiply 14 times 7. We're going to get 98. Actually, let me put exponential form. So we're going to get 98. We're going to keep the x the same, and we're going to add 2/3 plus 12. 2 divided by 3 plus 12. 38 over 3. Y to the 1/3 plus 2/3 is 1. Now you don't have to write the 1, but you can. How many fractions do you see there?
1.
So how many roots should you have? Meaning that 98 and that y are going to hop to the front. And you're only doing a root for the x. Okay with that? All right, so if I'm going over here and I'm doing radical form, the 98 and the y are not in radical form. The only root I have is for the x, because that's the only one that has the fraction. And I've got a 38 and a 3. What multiple of 3 did you use here? I like 36, which means this one's going to be a 2. Yes? And again, this 98y is just coming along. 3 goes into 36 12 times, but don't forget that there's an x on that. And then inside is less than outside, so we'll leave that part the same. So radical form would be 98y, x to the 12th. And you can switch the x and y. Like you could do 98x to the 12th y. That order doesn't matter. And then third root of x squared. We okay with that? All right, tomorrow we'll do quotient, division, and power, and we'll just do more check-in practice with that. Then Monday will be you know everything. Let's do stations and just practice these. Tuesday, test review day. Wednesday is your test on this stuff. No homework.